Dear students, today we will discuss one of the important part of the mathematics, that is the linear algebra, which is mostly in your B.Tech engineering mathematics first semester course. In B.Tech first semester course, the topics you will first come across, that is the linear system of equations. Linear system of equations. Okay. So you see, this consists of three words: linear system equation. Okay. So first let me explain you what is equation. Equation is any algebraic equation with equal sign. Algebraic expression with equality sign. For example, if we say 3x plus 5 is equal to 0, this is equation. Because 3x plus 5 is an algebraic expression, it means it contains unknowns and then it contains equal sign. That is why it is equations. But if we say 3 plus 2 is equal to 5, this is not equation. This is not equations, because equality sign is there, but this expression is not algebraic expressions, means it is not containing any unknowns. So if it is not an equation, then what it is? This is called identity. Okay. So this is the equations because it contains unknowns and equal sign, and this is the identity. This is not the equations. Okay. Then equation is over. Then you come to linear equations. Linear equations. So linear equations, it may contains one variable, it may contains multivariables. So if linear equations of one variable means the equations will contain only single variables. So it is an equation which degree is 1 and contains one variable. Example, if we say 3x plus 5 is equal to 0, how many variables are there? Only one variable. What is the degree of this equation? That is 1. So it is called linear. If I say another example, say 3x square plus 2x plus 1 is equal to 0. So this contains one variable, only one unknown, that is x, but the degree is 2. So it is not linear. So this is non-linear equations. Okay. So this is the algebraic form. If we think about the geometric form, every linear equations, it will represent, in geometry it represents a straight line. In geometry, a linear equation represents a straight line. But if the degree is not 1, a nonlinear equation, it represents a curve. It represents a curve. Okay. So this is the idea that what is linear equations, what is equation, and what is linear equations. Then we will discuss system of linear equations. Now we will discuss system of linear equations. system of linear equations. We know what is equation and linear equations. Then system of linear equation means we will have several equations with several unknowns. So system of equations means several equation with several unknowns, preferably same unknowns in all equations. Okay, let us consider one example. So I am considering 3x plus 2y minus z equal to 1, 3x plus 2y minus z is equal to 1. This is only one equations. Then I am considering 2x minus 2y plus 4z is equal to minus 2. And then I am considering minus x plus half y minus x plus half y plus 4z is equal to minus 2. Okay. So now see, this is one equation, this is another equations, this is third equations. But if we consider simultaneously and we call it as a star, means simultaneously we consider all the three equations, then it is called a system. It is a system of linear equations. First one is linear with two variable, second one is first one is linear with three variable x, y, z, second one is linear with three variable x, y, z, third one is also linear with three variables x, y, z. So when we consider simultaneously, it is a system of linear equations. And what about its solution? When we are given a system of equations, in every case we cannot give guarantee that we will have a solutions, right? And if the system of linear equations will have a solution, then that solution must satisfy all the equations. For example, for this type, the solution is xyz triplet that equal to 1 minus 2 minus 2, 1 minus 2 minus 2. Okay, so this value of xyz will satisfy these three equations. That is why we say this is the solution of this equation. But how this solution will get, we will discuss later on. Okay, then question is, always the system of linear equations may not contain three variables. It may contain any number of variables and with any number of equations. So how we represent a system of equations? So representation of system of equations. Representation of system of linear equations. So there are different methods. First one is general form. Second one is matrix form. Third one is vector form. Okay. Now we will discuss the general form of representation of a system of linear equations. General form of representation of system of linear equations. Structure is a11x1 plus a12x2 plus a1nxn is equal to b1. a21x1 a22x2 up to a2nxn is equal to b2. Like this, if we proceed, for m equations we will have a m1 x1 a m2 x2 plus a mn xn is equal to bn. This star represents a system of equations where this a11 a12 a1n a21 a22 a2n up to am1 am2 up to amn are the constants, where x1 x2 up to xn are the unknowns, where x1 x2 up to xn are unknowns, a11 a12 a1n am1 am2 amn etc. are constants, are coefficients, and b1 b2 up to bn are constants. This is the way that how we represent a system of linear equations in general form. Okay, then we will write matrix form. Matrix form. A mark. In this system of equations, we categorize the entire things into two. Some are the coefficients which are written in terms of aij, some are the unknowns which are written in xi, and some are the constants which are written in bn. Okay, so in matrix form what we will mention, so let capital X is equal to x1 x2 up to xn. This is a column matrix, means in the general form what are the unknowns we have written, that is x1 x2 up to xn, so that unknowns will be considered as a column matrix, that is capital X. Also you consider another matrix B by considering the constants which are available in the right hand sides, that is b1 b2 up to bm. Right, why we consider m? Because there are m equations, so there will be m constants. Why we are considering up to n? Because there are n columns, x1 x2 up to xn, so x. And after that we consider a coefficient matrix. Coefficient matrix is formed by considering a is equal to a11 a12 up to a1n a21 a22 up to a2n. Like this we will find am1 am2 up to amn. So this is the coefficient matrix. This is capital X, which constitutes the column vector or column matrix x1 x2 up to xn, and B is a column matrix which is b1 b2 bm. If simultaneously we consider these three and we write in a form of equations like Ax is equal to b, this is called the matrix representation of the system of equations. Okay, so this is the matrix representation of the system of equations. Ax is equal to b. This Ax plus b, matrix form of representation. Okay. Now we will discuss the third case, that is the vector representation of a system of equations. You see, before discussing the vector representation of equations, we should be aware of the general form, and this is the general form of representation of a linear system of equations. This is a11 x1 a12 x2 up to a1 and xn equal to b1. Like this we are writing am1 x1 am2 x2 up to amn xn equal to bm. That means this system says there are m equations, n unknowns x1 x2 up to xn, and in the right hand side there are constants b1 to bm. So if we try to represent this in vector form, we will consider, so let a11 a21 up to am1 is a column vector. This is a column vector. Similarly a21 to a22 up to am2, this is also a column vector. Like that we can consider a1n, a2n up to amn is also a column vector, right? And also we can consider b1, b2 up to bm, that is also a column vector. Okay, that means we are considering the coefficients of a single variable x1 as a column vector, then we are considering coefficients of x2 as a column vector. Similarly, we can consider the coefficients of xn as a column vector, right? And x1, x2 up to xn are the unknowns. So now we multiply x1 into this vector plus x2 into this column vector plus xn into this vector, that equal to this. So this is the representation of a vector form.